Welcome to this section of this course. Today I will be speaking about quadratic equations. Any quadratic equations, it is of the form ax square plus bx plus c equals to 0 of any polynomial with a, b, c should be a real number, with a, b, c should belongs to real number, as well as the highest power of this polynomial should be 2, okay, as well as the highest power of coefficient should not be equals to 0, meaning a should not be equals to 0, okay. If a equals to 0, then it's not a quadratic equation, okay. What is its roots? Now, since the highest power of x is 2, quadratic means qua means 2, so we should have two values of x, okay. So we call roots. Let alpha and beta be the two roots, okay. Then alpha, let's take alpha is equals to minus b minus, or you can say take plus or minus b square minus 4ac upon twice a, and beta equals to minus b plus, if it is plus then you take minus b square minus 4ac upon 2a, okay. Alpha and beta are the two roots, okay. Now the sum of the roots, okay. Now number one, sum of the roots means alpha plus beta is equals to what? Okay, we need to find. Number two, product of the roots. Product of the roots means alpha into beta is what? And number three, then difference of the roots. Difference of the roots means alpha minus beta equals to what? Okay, we need to find all this, okay. Now first let's find what is sum of the roots, okay. Alpha is this, beta is this. Now let's add these two. Now if I add these two, then alpha plus beta is equals to minus b minus b square minus 4ac upon twice a plus minus b plus b square minus 4ac upon twice a. Now let's take LCM. Since denominator are same, I will write one time over here, twice a. So this minus b square minus 4ac minus b plus b square minus 4ac. Since plus is there, so I will not change anything. This term and this term gets cancelled. What we have? Minus b, we get minus twice b upon twice a. So these two and these two gets cancelled. So this is equals to minus b upon a. What is b? So b is what? Coefficient of minus coefficient of x upon what is a? A is what? Coefficient of x square. Coefficient of x square. Therefore, the sum of the roots alpha plus beta is given by minus b upon a, or you can say this is same as coefficient of x. What is b is coefficient of x upon a is coefficient of x square, okay. What is product of the roots? Okay, now let's multiply this alpha into beta over here. So I will get into over here, this into. You consider this is y, okay, and this is y, okay. This is z, and we consider this is z. So remember, we have a minus b. We have a minus b into a plus b is same as a square minus b square, okay. So something like this a minus b means z minus y as well as z plus y. So what will get? Z square minus y square means minus b the whole square minus square root of b square minus 4ac the whole square into twice a is twice a the whole square. What I am doing is I am applying this formula. Okay. Now minus b whole square is same as b square minus square and square get cancelled. Why? Square root of x is same as x raised to half. Square root of x the whole square is x raised to half into 2. These two gets cancelled. What will you have? Only x. So therefore this and this gets cancelled. What we have? B square minus 4ac upon 2 to the 4 4a square. This b square and b square gets cancelled, and then minus plus we have 4ac upon 4a square. This 4 gets cancelled, 1a gets cancelled, but we have c upon a. Okay. Product of the root alpha into beta is same as c upon a. What is c? C is constant term, or you can say constant term upon what is a? A is coefficient of x square. Coefficient of x square. Now we need to find difference of the roots. Okay. Now what is difference? Means alpha minus beta. We have formula a minus b whole square minus twice ab plus b square. Instead of this, I can write like this: a square plus b square minus twice ab. Okay. Now, if I want to express a minus b the whole square in terms of a plus b the whole square, then can I like this: a square plus b square plus twice ab minus 4 times ab. If I subtract these two, then I am getting twice ab. Okay. From here to here is a plus b the whole square minus 4ab. What is this? This is a minus b the whole square. Now come back over here. We have alpha minus beta. So instead of ab, let's write alpha minus beta whole square is same as alpha plus beta the whole square minus 4 alpha beta. Why I am doing is because we want difference. Okay, we want difference. Difference is here, and we already have sum alpha plus beta. We already have alpha plus beta, as well as we already have product alpha into beta. We already have. Okay, so I can use alpha plus beta as well as alpha into beta over here. Okay, so that we can find the difference alpha minus beta. Okay, so is equals to what is alpha plus beta is minus b by a the whole square minus 4 times alpha into beta is c by a. Thus I am substituting its value. Okay, is equals to b square upon a square minus 4c upon a. So if I take LCM, a square b square minus 4ac, and on the left hand side what we have alpha minus beta the whole square. So if I need alpha minus beta, taking square root on both sides, taking square root on both sides. So what we have? Alpha minus beta, square and square gets cancelled. So we have square root of b square minus 4ac upon square root of a square is same as a. Okay, and this is called discriminant. Okay, so this same as d upon a. Since the difference is always positive, therefore we take modulus. Therefore this is same as square root of d upon a modulus, where d is discriminant, means b square minus 4ac. So this is difference of the root alpha minus beta. Now what is nature of the roots? Nature of the roots is decided by its discriminant. What is discriminant? Now we call discriminant equals to d square minus 4ac. Number one, if discriminant we call d. Okay, if d is greater than 0, okay, then roots are real and unequal. 3 and 4 are real number as well as unequal. Okay, if d is greater than 0. Number 2, if d is less than 0, then roots are imaginary, or you can say unreal or imaginary and unequal. And number 3, if d equals to discriminant equals to 0, then roots are equal, and if d is greater than 0, then roots are real and unequal. And if d is less than 0, obviously it's imaginary, or you can say non-real. Okay, and then if d is equals to 0, then roots are equal as well as real. Equal or real means what? For example, 3, 3 are real and equal. And then if these are less than 0, imaginary means what? 2 plus 3i. And if d is greater than 0, roots are real and unequal, something like 3, 4.